Hi everyone and welcome to this new Databricks demo. Today we're going to see the hints, so kind of instructions you can decorate your queries on Databricks that can change the execution plan. So all the details are present in the article linked just below in the description of this video, and here I'm going to show you different repartitioning hints, so the hints that change data distribution. So here I will start the demo by loading this simple function just to display the table organization. Later I will also trigger the demo environment cleaning because I tested it before. And while it's starting, we can already discuss the use case. So here, as you can see, we are creating an events table with five different origins, where the US should be the most common value. And it's made on purpose just to illustrate different input distributions and some data skew in the input. And I'm generating 1,000 rows for that. Okay, now let me just create the input table again. And great, so now we have I will show you this different data distribution. We should have much more US rows than for other countries. But when you check the data distribution, it's not necessarily the case, right? Because we have like an even number of files with consistent number of rows in each of it. Okay, so now let's suppose that I'm going to read these records, so this table, and to create different tables by using the partitioning hint. And the first hint is Coalesce, where, as you can see here, when I explain this query, we will create a plan with Coalesce targeting two output partitions. So let's just run the query. The query is very simple, right? I'm just selecting all the data from the event source by using the partitioning hint. And when it comes to the distribution, we can see that it was even more optimized under the hood because I have only one file left from the 8 files present initially. Now we are going to force this kind of data organization with the repartitioning hint. So here there is a shuffle involved, and there is no, so there is the shuffle involved here, and there is no way that Spark will not respect this demand of two output partitions for our table. So the query is running, and when I check the data distribution, I should see two output files for this partitioning hint. The third hint is again the repartitioning, but this time I'm gonna use the number of partitions plus the column. That will change the distribution even more, because when you analyze maybe the execution plan, you should see that we are doing the hash partitioning by country column. And if I compare it with the plan from the previous example, and let me just show you, you can see that it's a round robin repartitioning, so there is no column involved at all. Okay, so I'm creating the table again, and I will display the data distribution. And as you can see, I have my 4 files where all the US data went to this one, all the Brazilian to this one, and there were like Germany and Japan combined together here. Okay, now another hint, the repartition by range. So is a very similar to the column, but here the difference is that we are going to take the ranges from values. So we are going to store some kind of consecutive amounts in each partition. So let me just explain this. I will try to identify the shuffle repartition by number. Range partitioning, right, with the amount and explicit ordering statement and number of partitions. And now I'll create the table. And finally, I will run the query to check the data distribution. And as you can see, we have 4 files in each of the outputs. And what else I can show you is the data distribution in each of the partitions. You can see that it's continuous, like 2232, 2245, 456, 4566, 71767, 72. So there is no overlap in there. And finally, there is the rebalance. So it's not the last one, sorry. So there is the rebalance strategy, where you ask Spark or Photon to basically use the best strategy, the best output design possible for the files. So let me run the explain now. There is a shuffle, of course, round robin partitioning involved. And since we don't have a lot of data, we are going to create a single file with all the 1000 records, which is probably most optimal than having 8 small files like in the beginning. And you can also use rebalance with a column, like country in our case. Rebalance partitions by column, in that case, is the node used here with hash partitioning. And when I run the query, in our case, it will change nothing again because we have not a lot of data, so we end up with a single file yet again. And that's all. It was all for the hint part. It was all for the partitioning hints. I will record in a few minutes another demo about joins. It will be a different, separate video because it will be embedded in separate place in the blog post. So stay tuned and keep reading the blog post, which is in the description of this video. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.